Okay, carboxylic acids, another type of organic molecule. Um, the general formula is the alkyl group and then COOH. They have a terminal functional group, which means the functional group, the COOH, has to be at the end of the carbon chain. It can't be in the middle. And the naming is enoic acid, methanoic acid, ethanoic acid, propanoic acid, and so on. Just to give you an idea of what they look like, we'll come back to this slide. Don't worry about it for now. Don't worry about the technicalities of it. But this is what a carboxylic acid looks like. It's got a COOH on the end of the molecule. Okay, they are polar molecules. However, the short chain ones are soluble in water, which is also polar, and then decreasing solubility as the carbon chain is longer after that, because the non-polar part of the molecule kind of takes over. They have a higher melting and boiling point than most other hydrocarbons and also than alcohols. And that's because of the hydrogen bonding, which they have kind of a double hydrogen bonding, as we'll see on the next slide. They're a weak acid, and all of the ones that we're interested in are liquids at room temperature. Okay, so here we have a diagram showing the hydrogen bonding. So we have the OH, which is the requirement, or an H bonded to a highly electronegative element, in this case oxygen. That's the requirement for hydrogen bonding. So just to reiterate, what happens is this pair of shared electrons is pulled away from the hydrogen, leaving basically an exposed nucleus, which is strongly attracted to negative charges, as we have here. We have unpaired electrons on this oxygen. So we get a hydrogen bond here and also here. So we get two hydrogen bonds between each pair of carboxylic acid molecules, double hydrogen bonding. Okay, we're going to look at these reactions: preparation, hydrolysis, neutralization, condensation with alcohols, and substitution. Firstly, preparation. How do we make a carboxylic acid? We oxidize a primary alcohol. Now, if you've watched the video on aldehydes, you'll know that when we oxidize a primary alcohol, we get an aldehyde, which further oxidizes to a carboxylic acid. So it goes from a primary alcohol through an aldehyde to a carboxylic acid. And we can use acidified dichromate as an oxidant. Okay, hydrolysis, reacting with water, we get a carboxylate ion. So in this case, we've got ethanoic acid reacting with water. We get the ethanoate ion and hydronium ions. It's the presence of these hydronium ions that make carboxylic acids acidic. The presence of hydronium ions is what makes the substance acidic. Okay, neutralization. So carboxylic acids are acids. They react just in the same way that all acids react with things like metals, carbonates, bases, and so on. So firstly, if we react a carboxylic acid, in this case ethanoic acid, with a metal like magnesium, we get a salt and hydrogen gas. Now note the fact that even though this ion, this carboxylate ion, in this case the ethanoate ion, which is just the ethanoic acid molecule minus the hydrogen, it's a negative ion, but we tend to write it first. It's just a strange convention. Normally you write the cation first and then the anion, but with carboxylic acid, carboxylate ions, we tend to write the anion first and then the cation. Okay, reacting a carboxylic acid with a carbonate, we get a salt and carbon dioxide and water, just as if we were reacting any other acid with a carbonate. So the salt, again, we're writing the carboxylate ion first. So in this case, we've got sodium ethanoate. We still say it as with the cation first, sodium ethanoate. This one would be magnesium ethanoate. And reacting carboxylic acid with a base, we get a salt and water. So again, sodium ethanoate here and water. Okay, condensation is when we react a carboxylic acid with an alcohol to produce an ester. We're going to look at esters more separately. So it's called condensation because it produces water. So we're producing water. We're basically joining these two molecules by removing H2O. So we get H2O as a byproduct. And what happens is this oxygen bonds to this carbon here. And we can see that, that's what's happened here. That bond there is formed between the two molecules. The naming, we'll look more when we look at esters, but methyl ethanoate. So we call, you can actually see here, this is actually an ethanoate ion. So ethanoic acid minus the hydrogen, right? That makes an ethanoate ion. And then we've got a methyl group attached to that. So the naming is methyl ethanoate, methyl here and ethanoate here, methyl ethanoate. The reaction is slow, but we can catalyze it using hydrogen ions, or in other words, making the conditions acidic by adding an acid such as sulfuric acid. Okay, substitution reactions with PCl5 or SOCl2 or PCl3 is a substitution reaction. These other products over here aren't that important. What's important is the organic product, which is an acyl or acid chloride. So all we're doing is replacing the OH on the carboxylic acid with a chlorine atom, which is an acyl chloride. Okay, and that is carboxylic acids.